again to my mathematics online tutorial. Today we want to consider quotient rule and it's still under differentiation. Now, the first example is sin s all over cos s. We know that sin s over cos s is equal to tan s. But because we have sin s as the numerator and then cos s as the denominator, we use what? Quotient rule. Where from the formula, my u is equal to what? Sin x, and my v is equal to cos x. Now, we need to get the u. What is the u? The u means to differentiate u. And when you differentiate u, you will have differentiate sin s. You're going to have what? Cos x. And then for us to have the v, we do what? Differentiate v. And when you differentiate v, you have minus sin x. Alright? Now, all we need to do is to substitute u, v, du, dv into the formula. Look at the formula here. Now, let's go. V is what? Cos x. Du is what? Now, du is cos x. That is, cos x times cos x. Minus, what is my u? U is sin x. Then my dv is what? Minus sin x. All over, what is v? V is what? Cos x or cos s. Let me just try this way. Multiply by cos x. Now, cos s times cos x, we have what? Cos square x. Then we have to minus times minus, we have what? Plus. So sin s times sin x, we have what? Sin square x. All over cos s multiplied by cos s, we also have what? Cos square x. Alright? Now, from three identity, that is cos square x plus sin square x. Now say but cos square x plus sin square x is equal to 1. So from here we can therefore conclude that 1, this everything here is equal to 1 all over what? Cos square x. But do you know that 1 all over cos x is equal to sec x? So if 1 over cos x equal to sec x, we can therefore conclude that 1 all over cos square x will be equal to what? Sec square x. And that is why we normally say when you differentiate sin s all over cos x, you have what? Sec square x. Now, let's also consider another example. Now, let's consider again another example. This one is going to be cos x all over what? Sin x. Remember, sin s over cos x, we have what? Tan x. For this one, cos s over sin x, we have cot x. So we are asked to differentiate this, and we're going to use what? Quotient rule, because it has numerator and what? Denominator. Now, what is my u? So remember, my u here is what? My u is now cos x, and y my v is now what? Sin x. And as such, this will also change. Alright? Now, differentiating cos x, we should have minus sin x. And differentiating sin x, we should have what? Cos x. Alright? Let's look at it again. Differentiating cos x, we have minus sin x. And differentiating sin x, we have what? Cos x. Now, we'll substitute into the formula in the same way. Substituting to the formula, now we have what? My v is sin x multiplied by du. Du is minus sin x. Alright? Minus, what is my u? U is cos x multiplied by what? Dv. And dv is cos x. Then all over v square. What is v? Sin x. That is, since it's square, that is sin x times what? Sin x. Look at this one. Sin x multiplied by minus sin x. We have minus sin square x, then minus cos x times cos x, we have what? Cos square x. All over sin x multiplied by sin x, we have what? Sin square x. This is sin square x. Now, you know that minus is common, so we can factor out minus. Then we'll now say sin square x plus what? Cos square x. All over sin square all over sin square x. But remember again, I told us in the first example that sine square s plus sine square s equal to what? 1. But remember, we still have minus, so it will be what? Minus 1 all over sine square s. But mind you again, from trigonometry, 1 all over sine s is what? Cosec x. Therefore means my minus 1 over sec square s will become what? Minus cosec square x. Look at it again. I said sine square s plus cos square s is equal to 1. But remember, we have minus. So therefore, we will now have minus 1 all over sine square s. But from 3, 1 over sine x is equal to cosec x. But because our sine is squared, therefore we will now have minus cosec square s because of this minus. I believe with what we have done, we are good to go. Please don't forget to join us again in the next class. Thank you very much. Bye.